So on tonight's homework, students are going to be practicing something that we worked on in class today. So what they're going to do is they're going to draw and label a tape diagram. And the tape diagram is going to have a couple parts. So the first thing they're going to do, this is going to indicate how many to draw, and this is what should go in each box. So for this one, I want to draw 8 thirds. So I would draw a tape diagram and draw 8. And then this tells me what to put in there. Thirds, the unit that I'm going to place in there is 1/3. So students should be able to, from the first part, indicate how many parts of the tape diagram and then indicate what unit should go in each. The next part says, how do you show 4 times 2/3? Well, students should think about how to go from 1/3 to 2/3. We practiced this in class today. So students should be able to block off 2 and know that 1/3 plus 1/3 is 2/3. And again, they can just simply draw this underneath to show the connection. Once they do this, they can show then that 4 times, we can see here, 2/3. Because of the associative property, we're able to move those parentheses around here. What we're doing is then we're saying it's 2, 4, 6, 8, but we're always counting the unit as thirds. So students should be able to do that for 15/8. Here they should draw 15 boxes, put an 1/8 in each, and then here they're seeing that they want to count 5/8, so they would group them up in groups of 5. So here on problem 2 where it says write an expression in unit form to solve, there's a couple different ways students can do this. I'll show you a couple ways on each problem. So on A, they can think about this as just what we did above, 10 times 2 and then fifths. So this is what, when we say unit form, we're asking them to write the unit following that. And right now, 10 times 2/5, we would put the parenthesis around the 2/5. That's the unit we're working with. But like I told you in the one above, 10 times 2 can go into the parentheses because of the associate property, and then they can say this is like 20/5. This is a perfect answer to a problem like A. The other thing that they can do is work out the problem the way we did in class, where they're saying 3 times 5, 6 is like doing 3 times 5 over 6. So again, here's the first set of parentheses, then we're putting these in parentheses, getting 15/6. So students can use either of those on A, B, C, and D. On the back, my preference is that students solve this the way I just showed you in the last problem. So showing that 6 times 2/3 is like 6 times 3 over 4 and making 18/4. I prefer that students also put this in mixed number form, so taking that improper fraction, taking out however many whole are in the problem. So in this case, we could say 4 whole, which would be 16/4, and then what's left over is 2/4. So their final answer here could be 4 and 2/4. The idea here is that students are realizing that they're counting by 5/8, so they're going to multiply the whole number times the numerator, which was what I showed like this, to get 35/8. We also practiced it on a number line today, so either method that students choose to use will work. Okay, on question 4, they're showing how we can use this in a real-world problem. So we see that Miss Smith bought some orange juice. Each member of her family drank 2/3 of a cup for breakfast. There are 5 people in her family, so we want to know how many cups. So what we want to do is set this problem up as some number times our fraction. So the fraction students should be able to see is 2/3. How many people drank 2/3 in the house? They should be able to determine it's 5. Once students solve this, we want to put it into a mixed number. The reason is we want to know how many cups they drank. If we were to just leave this in improper fraction form, we'd know how many thirds they drank, but not how many whole cups. Just remember that 1 whole is equal to 3/3.